Hello everyone, this is Kusuma from 3rd year IT department of GRIET. Now coming to the abstract, the purpose of this main project is to design and develop a traffic assessment system. Nowadays traffic was a major problem in our world. Traffic may causes by different ways like accidents and driver getting stuck in the traffic jam during his journey and weather forecasting reports that leads to unexpected forced delays. The purpose of this project is to design and develop a traffic assessment system. Traffic estimate is determined by the amount of traffic congestion. The most common causes of traffic congestions are any driver getting stuck in a traffic jam on their journey. Accidents such as road accidents and road accidents often lead to unexpected unforeseen delays. Now coming to existing system. The current framework takes the manual inputs from the human beings which is processed by using a Flask server. There are many modules or frameworks which allow building your web page using Python like Flask server. So, however, this approach presents notable drawbacks like while taking inputs from the human beings may lead to insufficient of data, inaccuracies and noisy data. Firstly, relying on manual input introduces the possibility of inconsistency as it is prone to human error and can be time consuming. Furthermore, the existing system scope is limited as it does not comprehensively consider all influential factors affecting traffic volume, such as weather conditions and holidays also. Additionally, the scalability of the system is constrained, given dependency on manual input, which may hinder its ability to handle larger datasets or expand to cover additional locations effectively. So, to overcome the problems from the existing system, we came up with proposal system. The proposal system leverages automation and machine learning for traffic volume estimation, eliminating manual input errors. By automating data retrieval, including traffic patterns, weathers, and holidays like humidity, temperature, and wind speed, the system enhances traffic accuracy. So, scalability is addressed through a well-designed architecture capable of handling growing datasets and additional locations seamlessly. With a user-friendly interface, incorporating visualization and meaningful insight, the proposed system empowers users to make informed decisions. Integration of machine learning algorithm enables predictive analysis, adapting to evolving patterns and ensuring real-time updates for prompt responsiveness. So, by using this proposal system, we can implement a user-friendly interface. Coming to designing part, we have various types of UML diagrams. So, firstly we are going to discuss our project through an activity diagram. So, coming to the activity diagram, an activity diagram is a type of diagram in the UML diagram that represents the flow of activities or actions within the system or a business process. In this activity diagram, first step is loading the CSV data. The process starts by loading the data from a CSV file. This data is likely required for training the model, and next step, displaying the data. Once the data is loaded, it is displayed. This step is useful for visual verification and understanding of the dataset. In third step, we have to initialize the linear regression model. The next step is to initialize the linear regression model, which is a type of predictive modeling technique used to understand the relationship between the variables. Next, training the model. The model is trained using specific features from the data like temperature, rain, and humidity. This training process involves learning the relationship between these features and the target variable. And the next step, we have to display the data. After training the model, the coefficients of the model are displayed. These coefficients indicate the importance of each feature in predicting the target variable. The intercept of the model is displayed in the next step. This intercept is the expected value. So, coming to the next diagram, that is sequence diagram. In this, we have various components like user interface, raw data, cleaned data, trained model, and traffic estimation. Each interface having its own characteristics to describe about our model. So coming to the sequence of activities, the user provides data to the user interface. And next, the user interface collects the raw data and pass it to the cleaning component. The data cleaning component processes the raw data into cleaned data. The cleaned data is used to train a machine learning model. The trained model estimates the traffic volume based on the input data. The traffic estimation result is returned to the user interface. The user interface displays the estimation to the user. This sequence diagram helps you visualize the dynamic behavior of the system, illustrating how different components collaborate to process data, train a model, and provide traffic estimation to the user. Next, coming to the system architecture. In the system architecture, the workflow begins with user input to the user interface, which is then passed to the data preprocessing module for loading and preprocessing. The preprocessed data is sent to the model training to module initialize and train the linear regression model. Once trained, the model is used in the prediction module to make prediction based on the new user inputs. The prediction results are then displayed back to the user interface. So, this creates a loop of interaction where the user can continuously input new data and receive prediction. This diagram illustrates a linear regression system's overflow consisting of 4 main modules like user interface, data preprocessing, model training, and prediction. The user interface module involves a input from a user, data entry, and displays results section for showing prediction outcomes. The data processing model loads the CSV data and preprocesses it for model training. In the model training model, the linear regression model is initialized and trained with the preprocessed data. Finally, the prediction model uses a trained model to make prediction and display the results. The diagram shows the flow of data between these modules, highlighting the interaction and dependencies at each stage. So, coming to the implementation, for this project we have to take the data set which includes column for weather conditions like temperature, humidity, wind speed, and traffic volume. Each row represents a specific observation of traffic volume recorded at different times of the data under various weather conditions. So, we have to construct a model. For constructing, to make use of model features, we must first import the model using an import statement. The import keyword is followed by the module's names in the import statement. In Python file, this should be placed at the top of the code, right below any lines or general comments. So, for implementing the linear regression model, we have to import the linear regression method from sklearn. Here we can see from sklearn import linear model. Here we are importing linear model using the sklearn library in Python. After importing the library from sklearn, we have to train the model using the dataset which consists of attributes like temperature, rain, and humidity, which are the input variables, and the traffic is the output variable. From this, after implementing the linear regression, we have to check the coefficients and intercept using these coefficients and intercept methods. And at last, we have to predict the model. After construction, we came across user authentication. This HTML file sets up a user interface for estimating traffic based on the weather condition. It includes a form tag which can take input city name to get traffic information. Here we can see our code, HTML code, which is used to create a user interface for our project traffic volume estimation. In this we can we use a JavaScript code to initialize a speech recognition API listens from voice input, which is a microphone button is clicked, and updates the city name input field accordingly. The resulting traffic information is displayed in a hidden cart. So after fetching the data, we have to style the interface. For styling the interface, we used CSS. After the styling data, we have to take the information like weather information and display the traffic volume estimation. The display info function processes the weather data retrieved from the API and displays the relevant information on the web page. It is used to taking the input from the user and providing output which is user friendly. It extracts key information such as city name, temperature and humidity, wind speed and weather description. In this project we have used the weather API which is automatically retrieves the wind speed, humidity and weather description like it is rainy, cloudy, clear sky, light rain, etc. Based on the weather ID received from the API, the function assigns an appropriate emoji using the emoji ID. Like if it is raining, it will show the rain emoji ID, visually representation based on the weather condition. Additionally, it calculates an estimated traffic impact based on a formula involving temperature, rain if available, and humidity, and displays the estimation alongside other weather details. If any error occurs during the data retrieval or processing, the error function is called to display an error message on the web page. After the displaying the weather information and traffic estimation, here is the JavaScript code implementation. We can use this JavaScript implementation to provide an output on the user interface. So coming to the output, we have to enter a city name. For example, I have entered Hyderabad and press get traffic. It will estimate the traffic in units, and it also displays the temperature, humidity and wind speed and what was the weather nature. Like I have entered Hyderabad at this time. With this temperature, humidity and wind speed, it was showing light intensity drizzle with this estimated traffic in units. For example, I have entered another city like Nalagonda, get traffic, error. There is no city name like that because the spelling were wrong. So I have entered another input like Sarapaka, get traffic, and at Sarapaka we have overcast clouds with this much of traffic and with this much of temperature, humidity and wind speed. Finally, I want to conclude the video by thanking the project guide Dr. K. Ravikiran, who is Associate Professor in Gokaraju Rangaraju Institute of Engineering and Technology.